Okay, welcome back to the next question. The question number 2 in EEB3210 model web theory of electricity. The question is two capacitors, two capacitors of 9 microfarad and 4 microfarad are connected in series with each other and with a DC source of 26 volt. Let's draw the diagram. There are two capacitors, 9 microfarad and 4 microfarad are connected in series with each other in with the DC source of 26 voltage. Okay, let's discuss. Let's draw the diagram. There are two capacitors. They are connected to the DC source of voltage. Okay, we already know this is the symbol of capacitor. This next capacitor. This is the symbol of DC. So DC source. Source. What is the symbol of this? This is the symbol of AC source. This is the symbol. Sorry, don't cut this. Sinusoidal signal. This is the symbol of AC source. Okay. This is the symbol of AC source. We will not consider about here in this question. Okay. This is the DC source. We already know. The long line is plus. The short line is minus. Therefore, if the long line is plus, this is plus. Plus and plus will be if it is plus. If we uh, connect the plate by wire, this is wire. This plate will be plus. This is minus. Therefore, we connect this plate by wire to this negative. Therefore, this plate also will be negative. Therefore, if this is plus, this is a plus plate. Therefore, this is minus. This is minus. Therefore, plus. If plus, minus. If minus, this is plus. Okay, plus. Okay, very simple. We have already studied in advanced level physics also. We don't need to now. What are the capacitance of the capacitors? Uh, let's say this C1 capacitor 1 is equal to 9 microfarad. 9 microfarad. Micro means we already know 9 micro. Micro is equal to 10 to the power minus 6 minus 6. Micro is equal to 10 to the power minus 6. Okay. Okay. C1 is equal to 9 microfarad. C2 is equal to what is C2? C2 is equal to 4 microfarad according to the given data. Okay. Now what's the voltage? DC voltage. 26 voltage. Therefore we have drawn the initial stage. Uh, okay. Let's read the question. Now then the charged capacitors are disconnected. First, we discuss about this diagram. Here, the capacitors are connected in series. The capacitors are connected in series. Therefore, the charge, if the total charge of the circuit is Q total, you must memorize this. This is very important because most of the students make mistakes in this place. Okay, you must memorize this. Most of the students makes mistakes in this area. If the total if the total energy, total Q means charge, no? Q means charge of the capacitor. Q total means total charge of the capacitors. Is C1, C2. Total, if please assume that the total charge of the capacitor is Q total is equal to QT, okay? Is equal to Q1 is equal to Q2, which means if the total charge is Q, there are two capacitors. No, we can find the equivalent capacitance instead of we can find the equivalent capacitance instead of these two capacitors. We already know about that. We can find in later. This total the, the total charge of the capacitor will be uh, equal to Q1 and Q2. For example, the, the charge of this the charge of this 1 microfarad capacitor is Q1. Is assume that the charge of the first capacitor is Q1. The the charge of the second capacitor Q2 is equal to charge is Q2. Okay, if in according you already know if 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 any if any capacitors if we connect the capacitors in series, the total charge will be uh, uh, same. Every charge of the capacitors will be same. That which means if the charge of this capacitor is Q, the charge of this capacitor also will be. We don't need to consider about capacitance. It may be 1 microfarad, 1 microfarad. This may be 2 microfarad. Don't consider. We don't need to consider about. For example, there are many capacitance. There are many capacitance are connected in series. Okay, connected in series with a DC voltage. That time also, every charge of the capacitors will be Q. Q Q Q always same. The capacitance may be different. That's 1 microfarad, 10 microfarad. The capacitance of this is 100 microfarad, 200 microfarad. We don't need to consider about capacitance. Okay, we don't need to consider about capacitance. We if we connect the capacitors in series, the charge will be same. In parallel connection, we already know it resistors. Resistors, resistors. Uh, we connect. Okay, okay, connect in resistors. We connect the resistors in parallel. If the total voltage will be, if let's assume that the total voltage input voltage is V. The voltage of the DC voltage is V. Okay, V. V or V dash. Okay. Therefore, every therefore potential difference of the every potential difference of every resistance will be V dash. We already know, which means the voltage across this capacitor will be V dash. This also V dash. Here also potential difference V dash. Here also the potential difference of the capacitor will be V dash. So the total voltage also V dash. Here also V dash. The same wise, likewise in capacitor there are if you study about resistor and capacitor, the resistor and capacitor in most places the resistor and capacitor will be behave differently. Okay, we will consider. We already studied in advanced level. Okay, now if we here the total voltage will not be say will be same V dash. The likewise in capacitor if we connect there I already said that the resistor and capacitor will be act different oppositely. Okay, for example if this is plus this is minus, if this is minus if plus. Okay, here we connected the resistors in parallel, therefore the voltage same, voltages are same. Here uh, if we connect the capacitors in series, the their voltage same. Here uh, uh, charges will be same. Q Q Q Q. The capacitance may be different. C1, C2. This may be 1 microfarad. This may be 10 microfarad. This may be 100 microfarad. We don't need to consider about. Okay. Therefore, okay. Now let's move to the question. This is very important. That's why uh, I I told you many times because most of the students, according to my experience, the most of the students make mistakes in that area. Most of that's why I explain many times again and again. Okay. Now the capacitors are connected in series. Okay. Now here, for example, the total for example, the code you already know we can we can derive the equivalent capacitance instead of these capacitors. No, resistor also if there are two resistors are in series, we can we can find the equivalent resistor or equivalent using R1 plus R2. If we sum the if we sum the if we add the two resistance, we will get the equivalent circuit. Here, there is a that's the here also we find the equivalent capacitance instead of these two circuits, two capacitance. But therefore, for example, if the total energy, total charge of the capacitance is Q total, this is C equivalent no final. This R equivalent, this C equivalent. The total energy, total charge of the C equivalent is Q total. This Q1 is equal to also Q total. Okay, Q total. This is also Q total. Q2 is also Q total. You must memorize this very carefully. You must understand. Okay, that is very important. Okay, now okay, there are two capacitors connected in series with 26 volt. This is 9 microfarad. C1 is equal to 9 microfarad. 9 microfarad. C2 is equal to 4 microfarad. Farad. C1 9 microfarad. C2 4 microfarad. DC voltage 26 voltage. 26 volt. Uh, okay. C1 microfarad. The charge will be same. Q if Q. Okay. Q. Let's assume that this Q1, Q2. Here Q total will be Q total is equal to Q1 is equal to Q2. Q total is equal to Q1 is equal to Q2. Okay. Now let's move to the question. Now then the charged capacitors are disconnected. Then the charged capacitors are disconnected from the source and from each other. The charged capacitors are disconnected from. Now the capacitors are connected to the DC source. Now the capacitor now the charged capacitors are now the capacitors have we have charged the capacitors. Okay. Now now the charged capacitors are disconnected from the source. Now we have disconnected from source. Now the wire will be like that. Okay. Okay. And and from each other. Therefore, there is no connection between the now they are separate separate capacitors. Okay, from each other, and then reconnected to each other with sets of same sign together. Which means we already discussed about uh already discussed about okay. Sorry, this long line. So if it's plus minus, this plus, this minus, they are this is minus, they are this plus. Now they are connected. Uh, same sign, which means positive to positive, negative to negative, positive to positive, negative to negative. Therefore, this is what is the meaning of that parallel connection? Parallel connection. They say that connection, parallel connection, they connected to each other with plates of same sign together. Same sign together. Therefore, parallel connection. Already, already series connection. Already series connection. Now parallel. parallel connection. Okay. The by how much does the energy this by how much does the energy of the system change? They are asking how much energy changed. Initially the circuit was in series connection. Now the circuit is in parallel connection. Now they are asking about delta W. What is the energy difference? Okay, let's move to the question. Now we are going to discuss about initial stage. Okay, initial stage at initial stage at initial stage or at at series connection or or at series series connection. Please write. Okay, please mention important things like this before answering the question. Please also answer at initial stage or series connection. Uh, what we now we there are the capacitors are connected in series. Now we have to find the equivalent capacitance. C equivalent. How to find the C equivalent? C equivalent in series in resistance. If the resistors are in series, we have to sum R1 and R1 plus R2. But if the capacitors are in series, uh, we already discussed that resistors and capacitors are opposite. Here we have to find this equation. We have to some students confused here. They use this same equation. Addition here also. Don't use like that. If the capacitors are in series connection, you must use this equation. 1 by C is equal to 1 by C1 plus 1 by C2. Okay, 1 by C is equal to 1 by C1 plus 1 by C2. Now 1 by C equivalent is equal to, if there are three capacitance, it will be 1 by C1 plus 1 by C2 plus 1 by C3. We already discussed, we already studied in advanced level. Okay, we don't need to discuss about very deeply. See, I just memorized them. 1 by C equivalent is equal to 1 by, what is C1? C1 is equal to 9 microfarad. C2 is equal to 4 microfarad. 4 microfarad. Therefore, 1 by 9 microfarad plus 1 by 4 microfarad. 1 by C equivalent is equal to 1 by 9 into 10 to the power 6 farad. 1 by 4 into 10 to the power 6 farad. I multiply by, we have to equal the denominator. Therefore, I uh, we- I multiply by 4 in denominator and numerator. Here I multiply by 9. Here by numerator and denominator and numerator. Now, now the denominator is same 36 into 10 to the power minus 6. Here also 36 into 10 to the power minus 6 farad. Therefore, we can 1 by C equivalent is equal to, now the denominators are same. Therefore, we can uh, uh, sum directly. 4 plus 9 is equal to 13 divided by 36 into 10 to the power 6 farad. Now C equivalent is equal to 36 by 3, 13. C equivalent is equal to 36 by 13 into 10 to the power minus 6 farad. Therefore, C equivalent is equal to 36 by 13 micro microfarad microfarad. Okay, C equivalent is approximately equal to, if we write 36 by 13, we will get the final answer that 2.769. 2.769 microfarad. Because we do yeah, it's the continuous equation therefore C equivalent is approximately equal to 2.769 microfarad. Don't use this, mostly don't use this 2.769 microfarad, this number to the questions, because C equivalent is approximately equal to, not exactly equal, approximately equal to 2.769 microfarad. Therefore, uh, please use this equation. That is this number 36 by 13. Therefore, you will get the answer very accurately. Okay. If you want to substitute instead of C equivalent, don't substitute this number. Okay, please substitute this number 36 by 13 micro. Don't forget this micro. Okay, there you will get the very accurate answer. Now we have find the C equivalent. Now, okay, now already the capacitors were in series C1 and C2. Now we have found the equivalent circuit C equivalent, which is approximately equal to 36 by 13 microfarad. Okay. Now we have found C equal. Now we have to find the total charge. How to find the total charge? We have to find total charge. You have to find the total charge. There's equation. We have already studied in advanced level physics. Q is equal to CV. Q is equal to CV. Already know. You can this Q. This is C. Okay. They have a C. This is V. This is small trick. This is Q. They have a. This is C. They have a C. This is V. They have a V. Q is small trick to memorize. Okay. Uh, sometimes you may confused in exam that whether Q is equal to CV or V is equal to QC. You may confused in exam. Therefore, if you please memorize, please understand in any tricks. Okay, it will be useful in exam times. Okay. Now Q total, we have to find the Q total. Q is equal to CV. Q total. Q total is equal to what is C? C equivalent. C equivalent is equal to 36 by 13 microfarad. 36 by 13 microfarad farad into what is voltage? We already they have given that 76 voltage DC voltage. If you find If you calculate, you will get fine answer. Q total is equal to okay. 13, 26. They have two times. They have 36 into 72. 36 into 2, 72 micro coulomb. Micro coulomb. You you know the unit of the charge is coulomb. They have 72 micro coulomb. They have Q total is 72 micro coulomb. They have the capacitors are in series. No. Now we have found this is the initial stage. We assume the diagram is equivalent circuit. This is C1, this is 2, C2, this is C equivalent, the same voltage. Here we found the Q total. Q total is equal to 72 microfarad now. 72 microfarad. 72, sorry, micro coulomb. Micro coulomb because charge no. 72 micro coulomb. Therefore, the charge of the capacitor, the charge of the capacitor C1 will be 72 microfarad. Like uh, we discussed about in series connection of the resistors, there the total voltage will be the voltages of every resistor. Likewise, here Q total 72 microfarad will be equal to Q1. Q1 is equal to 72 microfarad. Q2 is equal to 72 microfarad, farad, which is equal to Q total. It's very simple. Okay. Now we have find the total charge 72. So 100 no 700 72. Okay, 72 micro coulomb. Uh, C equivalent 2.76 now. Why did we find this? Because we have to find the uh, initial energy. Because the question is, they asked in the question that what is the energy difference delta W? What is the then therefore we have to find the energy difference. Now, what is how to find the energy? What is the equation of W? W is equal to half into Q into V, half into Q into V. We can memorize like that. This W, no, this is small trick. Uh, Now this is Q, this is V. Therefore, half into QV is small tricks. W, W. If you now this Q, this is V. Small tricks. W is equal to half into QV. Don't forget this half. Okay. This is the energy of capacitance. We already studied in advanced level. W is equal to half into QV. Therefore, W is equal to half into Q into V. Now, what is the total energy of the energy of the capacitors? Half into Q total. What is Q total? 72 microfarad. Sorry. Microfarad, no, microcoulomb. Okay, microcoulomb. Sorry, microcoulomb. They are charge, no. Farad is capacitance, no. Half into 72 microcoulomb into what is the voltage? Voltage is 26 voltage. Okay. Now W total is equal to final equal to 36. 26 into 36 into 26 will be 936. If you calculate 900 and 936, 936 6 microjoule. Okay, microjoule. The unit of energy is joule. Therefore, W total is equal to 936 microjoule. This is the energy at this is the energy at initial condition. Initial condition. Initial condition. O in series connection. Okay. Now we have find the total energy in initial condition. Now we have to find the final energy. Now they have mentioned that the capacitors are connected say, positive to positive, negative to negative, which means parallel connection. Okay. Now this is C1, this is 2, C2. The capacitance C1 charge Q1, capacitance C2 charge Q2. But the voltage will be same because parallel connection, their voltage will be same. Here also V voltage, here also V voltage. Now there is no battery because they are disconnected from battery now. They have already mentioned in the question. Now we have to find the here. Now the capacitors are connected in parallel. They have in the parallel connection, in parallel connection, in parallel connection. Please write this. Okay. O in parallel connection. O in final stage. In final stage. In O at okay at parallel connection. O at final stage. Final stage. Please write anything in exam. Okay. It, C equivalent is equal to how to find the C equivalent to parallel connections of capacitors. We already discussed that the resistors and capacitors are opposite. In if the capacitors are in the resistors are parallel, we will find the equal resistance by this equation. You already know 1 by R is equal to 1 by R1 plus 1 by R2. But the capacitor is opposite. The capacitors will behave oppositely to resistors. Therefore, the capacitors are connected in parallel. Okay, I'm recording. The capacitors are connected in parallel. Therefore, the phi C equivalent will be C1 plus C2. C equivalent is equal to C2 1 plus C2. Very simple. C don't confuse with resistors. Okay, please write these uh, equations very carefully. Don't confuse with the equations of resistors. These are capacitors. These are important things here. C equal is equal to C. What is C1? C1 is equal to 9 microfarad. We already discussed 9 microfarad. Then 9 microfarad. C2 is equal to 4 microfarad. Therefore, C is equal to 9 plus 4, 13. 13 microfarad. Now we have find the equivalent capacitance of the parallel connection. Okay, the capacitors are in parallel. We found the C1, C2. This is the C equivalent. This is equal to exactly equal to 13 microfarad. Okay. Now we have to find the energy of. Now we have converted two capacitors to uh, one capacitor, equivalent capacitor. What is the purpose? To find the answers very quickly. If there are many capacitors, we have to find the total energy one by one. If we convert convert to one equivalent circuit, we can find the energy or anything very quickly. This is not a new thing. No, we have already studied in advanced level. Therefore, we don't need to discuss about more. Okay, now we have find C equivalent is equal to 13 microfarad. Now that the total uh, the charge of capacitor one is Q1. This is Q2. Q1 is equal to what is Q1? We already discussed that Q1 is equal to Q. Uh, we already discussed. Okay, Q1 is equal to here. No, in initial stage, Q1 is equal to okay. Don't confuse here, okay. In initial stage or in series connection, we already discussed that Q1 is equal to 72 microfarad. 72, yes, 72 microfarad. Q2 is equal to 72 microfarad. Q1 is equal to 72 microfarad. Q2 is equal to 72 microfarad. Q total will be also 72 microfarad. We have already discussed about this. Okay. Now, what is the total energy? According to the theorem, the total energy, total charge will not change. The total charge will not be changed. They are constant. Already the capacitors were in series connection. Then they were converted to parallel connection. The energy will be changed. Why the energy will be changed? We will get some energy lost. We will lose some energy because if we connect the capacitors in parallel, we will find spark spark spark. One we will get spark. Other one we will feel heat. Yeah, will if we connect the capacitors in series, parallel, there will be current flow through this wire. So equivalent, there is will different voltage in parallel connection. There will be different voltage. Here the voltage will be same in parallel connection. We already know. This here is the same in resistor and capacitor. Okay, don't confuse. Therefore, to equal here the voltages are different. The potential difference are different. If we connect the capacitors in parallel, the voltage will be same. How it will be same because the current will be flow from through this wire and uh, the voltage will be same. Okay, the charge will be go. Okay, therefore we already know if current flow through the wire, we the 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 conductor will be heated. The temperature of the conductor will be decreased. Therefore, for spark, for mainly two reasons, we will get energy loss. One is for spark by light, by heat. We will get energy loss. Therefore, W will be changed. The change. W will be changed. Energy will be changed in series. If we convert the series connection to parallel connection, the W total energy will be changed because of spark and heat mainly. But in initial stage, they were in series connection. Now they are in parallel connection. But the total uh, 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 total uh, total charge will not be changed. Okay, according to the theorem, charge conversion theory. According to the theorem, the total charge will not be lost. The 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 theorem says that the total charge will not be the charge will not be created or destroyed like energy. We already discussed about the energy will not be created or lost according to the law. Likewise, but here Q will not be changed. Therefore, what is the Q total? Q total in at now we are looking. We are consider the at parallel connection. At parallel connection or final stage. At final stage, Q total is equal to Q1 plus Q2. Q total is equal to Q1 plus Q2. Q1 is equal to 72 microfarad. Q2 is equal to 72 microfarad. Okay. You may have doubt that in the initial stage, the Q total will, in series connection, the total microcoulomb, okay, microcoulomb, 72 microcoulomb. Uh, if you look at the series connection, there will be Q total will be totally 72. But here 72 plus 72. This is the very important thing in this equation. Okay, they are the capacitors were in series. They have a Q total, Q total, Q total, Q1. This Q1, this Q2. Q1 is equal to Q total. Q2 is equal to Q total. Now we have to we have Q1 is equal to Q total. Q2 is Q2 is equal to Q total. Here we have to sum Q1 plus Q2. Q total is equal to Q1 plus Q2. There we have already discussed this. Total Q total is 72. Not only the every charge of the capacitor will be Q total. Here in parallel connection, we have to sum the charges. If there are if there are many if there are many capacitors in series connection, we have to this Q1, Q2, Q3, Q4, Q1, for example, Q1, Q2, Q3, 4. If we connect to the total charge, assume that the total this is a series connection, the total charge is Q. Therefore, Q1 is equal to Q, Q2 is equal to Q, Q3, Q3. is equal to Q, Q4 is equal to Q. If we converted to parallel connection like that? Sorry, parallel connection. Here we have to Q will be Q total days, Q total days. Here Q total in parallel connection will be Q1 plus Q2 plus Q3. But Q1 is Q, Q2 is Q equal to Q2 is Q. There were three Q like that. Okay. Therefore, in our equation, Q total is equal to Q1 plus Q2. So Q1 is equal to 72 microfarad, micro coulomb. Q2 is equal to 72 microcoulomb. Therefore, parallel connection or final state, parallel connection or final state, Q total. Yeah, Q total days. Okay. Because in initial stage we found the total we assume that total energy is q total. Therefore here q total is equal to 72 plus 72 144 4 microfarad microcoulomb. Don't confuse with these units. Okay, 144 microcoulomb. Okay, I also make mistakes in this in my notes. Now we have find the total charge and equivalent capacitance. Now we can find the total energy. We can find the total energy. Total energy at parallel connection or final stage. The what is the equation of energy? W is equal to half into QV. W is equal to half into QV. The W total days. Because in initial stage we assume that the total energy at final initial condition is W total. Therefore, not same no W days total. Or you substitute W to anything. Half into Q into V. Q equivalent Q total. What is that Q total? Q days total is 144 microcoulomb. 144 microcoulomb into uh, half into Q into V. But here we don't know V voltage because we didn't connect battery. The capacitors are only connected. There is no battery. Therefore, we don't know V. The equation is W is equal to half into Q into V. No, half into Q into V. But we don't know V. Therefore, we have to substitute anything instead of V. We already know Q is equal to Q is equal to CV. Q is equal to C into V. Therefore, V is equal to Q by C. V is equal to Q by C. Therefore, W is equal to half into Q into V. We substitute Q by C instead of V. Therefore, W is equal to Q square Q square by 2C. W is equal to Q square by 2C. Now we know Q and C. Therefore, we can find the total energy at final stage. W total days is equal to what is the Q equivalent? Q equivalent. What is Q total? Total Q will be Q total is 144 micro coulomb. 144 micro coulomb. 144 into 10 to the power minus 6 whole square. Q square by 2 C no by 2 into C. This is C equivalent. What is the C equivalent? Q1 C1 plus C2. They are both 13 micro coulomb. Microfarad capacitance no. They are both 13 microfarad. That is 13 into 10 to the power 16 farad. If you find the final answer, the final energy at final stage will be W dash total is equal to approximately equal to 700 797.54 microjoule. If you calculate very carefully, you will get this answer. Please use your scientific calculator at exam. Don't waste your time. If you if you calculate the equations by mind, you will spend a lot of time. Please bring calculator to exam. Don't forget. Okay. Now W total test is equal to 797.54 microjoule. Now what is your question? Question is W delta W. What is the change in energy? Change in energy. Change in energy. Here also we have to uh, change in energy is equal to energy at final W total days minus W total. Don't write the equation like W total minus W total days, because we already know change will be considered from final to initial. Therefore, final answer, final energy is W days total. Initial energy, total energy is W total. Therefore, uh, uh, we have to subtract from final to initial. Therefore, W total days minus W total. We have find W total, which is equal to 797.97.54 microjoule minus W total at initial condition is W total 936 936 point microjoule. Here this is 770 approximately 800 joule. This is 900 joule approximately. We subtract from small value to big value. Therefore, we will get minus. But what is the reason of minus? Because energy loss. The last energy is small. Initial energy is energy was high, because we found the energy loss because of spark and heat, mainly spark and heat. Because therefore minus, the final answer will be minus 138 138.46 138.46 microjoule. This is the final answer. Okay, final answer. The change in energy change minus 138.446 microjoule. This is the energy loss. We have find the energy change in energy. This is the final answer, which means energy loss is equal to, if they have asked us what is the change in energy. Therefore, this is the answer minus. You must include minus, otherwise the answer is wrong. Change in energy is minus 138.46 microjoule. If they ask the question that energy loss, if they ask about the energy loss, we have to write again that loss is equal to energy loss is equal to, don't, energy loss will be always plus. Okay, don't include minus 138.46 138.46 microjoule is the answer. If they ask that energy loss, now they ask that change in energy. Therefore, the final answer is minus 138.46 microjoule. Okay. This is the question. I mentioned some important things. Don't forget them. Okay. Some don't confuse. Mostly the students make mistakes, and in that places, please be very careful. Okay. If you like this video, please like and subscribe. Thank you. Let's meet at next video. Okay. Bye.